So this is the Raspberry Pi Zero, which we're all moderately familiar with, famous for being almost impossible to get hold of. One of the things that was actually done with the Pi Zero was got the traditional, do with more lasers. Where's that point? They got a pointy thing. I'm going to go tech. It's like lasers, but you can take people's eyes out even nastier with it. It's like a laser, but it hurts more. Traditionally on the Pi Zero, power in here, and that's just a power connector, USB out here, jobs are good. Now what they actually did on the Pi Zero is they actually wired up all the connectors on the USB. I mean, it can be something called USB on the go, which is, actually I'll stick to that screen for the time being, which is what you quite often get on mobile phones. So it can not only be a USB host, as they call it, so it can talk to mice and keyboards and blah blah blah. It can also pretend to be a USB device talking to other stuff. Happy days. So, I'm going to click to it. Yes. So it can be a USB device as well as a host. It can tend to be a keyboard, serial port, network adapter, instead of actually just actually using one of those, which is great. So that's why it could tend to be a network adapter, for example, and that's what we're going to be using a bit in a minute. This is where it gets slightly weird. There's some great code that someone wrote in the kernel, which basically means there is a kernel module you can load into it, but looking up inside, let's take this as being a Pi Zero I'm going to use for this. From what the Pi Zero sees inside itself, it sits there and says, oh yes, I've got an Ethernet adapter. Meanwhile, this module lies through its teeth down the USB port to the computer you just plugged it into, and it also says, I'm a network interface. It is in fact not a network interface at all, it pretends to be one and backs to back the two networks. So it looks like, there we go, oh, I got this right. You've got the host computer, which is what you'll be plugging the Pi Zero with this into. It says, yes, I'm a network adapter. And the Pi Zero says, yes, I'm a network adapter. Both machines think they're on a network with just the two devices on it and nothing else. The software can't tell the difference. It looks as though you've got one Pi, you've got the Pi on a network, there's the other machine on a network, there's a bit of cable in between them, and that's the lot. In fact, the only bit of cable is the USB lead. All fun and games. Andrew Mulholland did a lot of the original work on this and actually spotted this and collected together a lot of information from around the internet on how to actually do this. It's actually just a couple of simple edits to config.txt and command line.txt to put it into what they call gadget mode. In other words, pretend to be a USB device rather than a USB host. I'll just quickly flip through those. It is that single line in config.txt which loads this particular module saying, I want to be a USB gadget. I have no idea why it's called DWC2. Because I looked for the source code, there's no mention of it. There's probably some horrible pun in there somewhere. The slightly more different one is on the command line.txt, where you say modules load, so it loads DWC2, just W make sure, and G underscore is the gadget mode. CDC stands for something about pretending to be a network connector. So it basically, actually, it's even worse than that. Not only does it sit there and say, yes, I'm a network adapter, it also says, and a serial port whilst I'm about it. And it backs to back the serial port and it backs to back the network ports, even though there aren't actually any serial ports or networks. Right, so that actually is what we're going to do. So I'm going to close that one down and then suddenly realise I need to plug in a keyboard because it's something to actually go and do it. What I've actually done here is a slight variation on that. There's a few extra parameters which we'll have a look at in a minute. And what I've actually done, let's switch over to this one actually, HDMI thing, isn't it? HDMI 4?
4, yes.
there's a light you can put on this. So I'm plugging this keyboard in. So what we've actually done here is cheat a bit. It's probably best to draw this out. What you'll see in, where's the light on this? I don't know. There's light buttons on there. It's a small mark lamp. Hurrah! Bit better. Colour balance, guys, seriously. What you're actually seeing there, it's so hard to do in mirror. I managed to get hold of four pi zeros, which you can probably make out. I can prop that up. It's going to collapse horribly, isn't it? That will almost do. What you've got here is 4 pi zeros, because hey, why do you want when we can do 4? This is where the clustering comes in. 3 of them have got lots of nice blinky lights on top because, well, blinky lights really. And the 4th has got a display pointing forward, which I'll tweak around. So you actually get to see things. I thought there's a brightness on the light somewhere. Anyway, so you've got 4 pi zeros across there. Whoops. You can just about make out the 4 pi zeros. 1, 2, 3, 4. The 4th one on the front has a microdot fat on it, which has got a nice little display there. The other 3, which you can't plug stuff in, has got upwards pointing LED displays. All great stuff. In fact, this is the very machine we're using to give that demonstration. What we've actually done here is we talked about the pi zero. Oops. This is the world's worst colour balance.
Switch the light off, I think it worked better without.
It does, doesn't it? So what you've got here, actually just a pointy thing, is we've got a pi zero set up as I just described, USB lead that you'd actually plug in. Great. This takes that to the next level. It takes on the red wire there, it takes the USB out of the Pi and puts it onto this cluster hat thing. Now the cluster hat you don't need to use, it's something like about £35, so it's not fantastically cheap. In fact, it costs significantly more than the Pi zeros that are on it, ironically enough. It does two things that make it much more convenient. You've got the one connection coming out of the Pi, so there's your USB, and it's got another inbuilt USB hub on that board. So it goes in, and you get 4 USB ports coming out, which go one to each of the Pis. So you can now plug 4 Pi zeros in rather than just one, because we can, and it sounds like fun. So you've got your 4, as Z allegedly, got your 4 Pi zeros here, each hooked on to this USB. That's on the cluster hat board, which is just such a neat way of doing it. You can do it a lot cheaper without it, but it's just convenient. That then goes through to the Pi, which has another USB hub here, which gives you the 4 ports. So it's the one going out to the cluster hat, plus 3 others. So I've got a mouse, I'm going to have a keyboard in a second, there's still one spare. That goes through to the actual BCM processor on the Pi. So I should also point out there's a Pi on the bottom, which is actually controlling all of this. So far, so good. The other thing, I mentioned 2 things that this board gives you. Gives you the USB hub there. It also allows you to individually control the power to each of the Pi zeros. You could just plug them in and unplug them. But I'm basically lazy, and this makes life a lot simpler. I've also got to thank Pomeroni here for actually coming up with the goods and actually getting me some Pi zeros to do this with. I've actually used the original Pi 1.2s without the camera port. There is actually a reason for this. The ones with the camera port on, they move the active LED is a few millimetres in from the edge of the board. These ones, the original Pi zeros, the active LED is on the side of the board. so it's much easier to see. Okay, so let's switch back to plug the keyboard in. Because now what we're going to do, as you can see, there's a nice red LED on that board that's looking like it's white, and that just means the board's powered up. It's now time to have a bit more fun. Figure out where some sockets are. Okay. So what we're now going to do is put the display switch on. Oh, sorry, no, it is mine. So we're now going to go back to HDMI 3, VGA 3, HDMI. So HDMI 3, there we go. Yay! So now what we'll do is we'll get the terminal up, and this is where I hope I can remember this. Rather amusingly, the documentation for this board has a lovely hand-drawn diagram which ports control which. So this particular Pi I've renamed C0 because that's cluster Pi 0. It's going to be a bit tricky to you. I'm just going to run a read show on it because why not? The first thing we can do is you can use the GPIO command, which comes with wiring Pi. We can sit there and say GPIO write, GPIO pin 21, 1. And this has a really useful effect, so we switch back to there. I'm going to slow a bit flying on that. Come on, switch back now. Oh. Right, for those of you paying wonderful attention, you notice that by turning that particular pin on, we now have a blue LED has come on the board. That's what pin 21 does, it just turns the blue LED on and off on the board. So it actually does make sense because you can use it for sort of, it's all gone pear-shaped along. So far, so good, all pretty boring. Now this is where it starts to get a bit more fun. What? Please come back. Yes. We're now going to write, not just a pin 21, we're going to write pin 22. You can tell we've been playing this a lot, so I can remember the numbers off by heart, but they do all run in sequence. We turn pin 22 to a 1. By the end of this talk, I'll get the right buttons to press. Or possibly not. Some multiple ports, isn't it? 4. Yes. What's not terribly obvious from that is we've now got, which is quite useful, we've got the blue LED, which doesn't look terribly blue on this. That's just the LED we can flash. That's the power LED there. We've now got another LED on here. That means we've actually powered up one of the 4 Pis. All well and good. I will get this right. So now, what's changed? From the main Pi, you can't see an awful lot of difference. If I have an ASCII to look at all the internet or network interfaces, we've now got Ethernet 0, not connected, loopback interface, happy days. Pi 1 is now up and running. Now I've slightly tweaked this, put some extra parameters in, because I wanted to consistently come up as Pi 1, not in the order you turn them on, because suddenly what could be the first one turns up as Pi 1, and you might turn on the third one and turn the first one off and you get weird orderings. So I've done some, our tutorials, in fact, on the people who make the cluster have got a good tutorial on how to do all of this. But I now have Pi 1 up and running. So I've now got the first of those Pis in, and it just looks like it's on the network. So we can SSH to, now I called the interface, I use something inside the kernels, actually inside the configuration files, to rename the interface. It actually comes up, the first one comes up as USB 0. I sit there and say, if you get any interface called USB, anything, and it has this MAC address, which I use to identify each particular Pi, because we code the MAC address in, then rename it. So I've renamed that one to Pi 1. Similarly, I've got a C1, which is the host name. So I just SSH into that, bang. Now, you might not see this as much, but I've now logged into the Pi 0 on the top that's actually nearest you. So what we can actually do is have a bit of fun here. Well, this is going to work. So we're actually logged in from one Pi to another Pi. Well, I've got the exports running. Apparently not. I'm going to take it some time. Yeah, share is exported. Why don't you want to mount it? Come on, own up. That's slightly embarrassing. What we'll do in the meantime is we'll go back up. I think it needs to be on the network. We'll also turn on 23. Good. 24. And 25. Really nicely, they're consecutively numbered. So I've now turned the power on to the remaining 3 Pis. Chug, 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 chug behind the scenes. And if we now look at what interfaces we've got, interface Pi 1, Pi 2, Pi 3, Pi 4. So the host Pi on the bottom is just seeing what it thinks is 4 network connections. And those 4 Pis are now booting. If I switch back to the camera over the top, you can probably see all the yellow LEDs on the right hand side are now on. That's showing that all the 4 Pis are all powered up. The reason why I wanted to go to the Pi 0 original version, hopefully we can now see, because you can see almost the green LEDs. Actually, you really can't make them out on that, unfortunately, but they're much more obvious if you look at it. You can see this from here. The green LEDs that are now facing you are the LEDs on the side of the Pis, and because they're on the edge on the original Pi 0s, you can actually quite clearly make them out. Hence my use of Pi 0s. Yeah. So it's timed out. I'll be timed out. Well, it seems a bit bizarre because that's the machine we've actually logged in on. NFS is running. It's slightly annoying, but this basically is the call behind it. And that's not doing, I have no idea why it's not doing the networking, but we can log onto the second Pi there.
How are you assigning your IP addresses?
I'm using statically, yes. Actually, this is a key thing because no root to host. Why is it not setting the networks up? This is Johnny embarrassed.
It's a demo.
Yeah, actually, someone else is saying about this. C3, are you there? Yeah, it might be worth a shot actually. C1s there, that's cool. That is bizarre. So, well, these have all come up. Yes, what I actually did was I used fixed addresses and all the interfaces, he said, and it should, it's all static.
How do you use separate subnets for them?
Yeah, if you look at the net mask, it's all those /30nets. So, okay. So how come the first one came up and the others don't? That is
I've motivated you quite a lot.
Oh, actually, bizarrely, 3's come up now. Oh, hang on. Are we not being patient enough? C2, you can... I think it's just taking a little while for those machines to reboot. So we've got 1's come up, 3's come up. C4, anyone? This is a rather rubbish version of this. Why isn't it? Yeah, I think you're right, you've had trouble with on the go as well, haven't you?
Yeah.
Because this base...
Power often. I've ended up powering them separately.
This is actually worth mentioning. I was trying to get this to work earlier, and it was giving me an awful lot of trouble last night, until I realised I was using a cheap USB lead, and there wasn't, everyone knows where this is heading, and there just wasn't enough power to get through. The workaround for that is you use 2 USB leads. These are actually some nice ones I just bought. I got so annoyed with the cheap and nasty USB leads, I just went and bought a whole lot more. So you can plug the power one in as you traditionally would, then you plug this one in as well, so you get twice the power flowing into the device, which seems to make it a lot more stable. Although I am still rather surprised that this won't work. We've got 2 of the 4 have come up, which just makes no sense to me.
Put off more again. Can you do it with 2? You don't.
I'll try, well, in many ways we have. I was actually demonstrating, though it's not immediately clear from this, I can't have a shared drive either. I don't know. Connection, how can the connection time out if we're logged into it? That doesn't make any sense at all.
It's going back, you're logged into it, but it's trying to mount back to the host, isn't it?
Yeah, well, the route to 191 is on USB 0. If I do ping 192.168.1.1, it can connect.
It can't mount.
But it can't run the mount on it, which is just bizarre. How am I doing for time too, by the way?
You've actually got another quarter of an hour. Oh, you'll do quarter past.
So I'm Sun RBC, right?
Okay, you have less time. What time did he say?
No.
Oh, 5:02. Okay, you should be finished by now, Phil.
What's the other one? RPC buy, what I was confirming at best when we're starting the process out. Yeah, so what I'll do, for the shamefacedly leave that to now. If there's any questions on any of this, by the way? It's proving tricky that I've got some good tutorials out there. I'd recommend all the
one that I just went out on OTG networking.
Absolutely. So actually, this is quite good. What I'll do is, actually, do you want me to leave this on? Is this of any use to you on your own stuff?
I need to get all this up.
Right, okay. What I'll do is I'll shut all this stuff down. I'm still annoyed. So we can go on to this one. Actually, I'll show you how you shut it down cleanly. So we actually sit there and hit halt on the machine C1. We can then go back and look at the GPIO command. So while that machine's shutting down, we can go right to port 22. So that machine's shut down, we can now elegantly power it off. And in theory, though it's quite tricky to do, you can actually pull the cards out. So that's 0, 1 shut down, 3. We can power down. bit, and that was 22, 23, 24 with that one. And power you down. One last chart to figure. I do not understand why. C3. Oh, he's claiming that on C4. I have no. C2 and the. Why on earth? That just makes no sense to me. So what I'll do
next time we record a live video.
Yeah.
Rehearsal. Saying that I've got my stuff set up.
So what? I'll just give you some time to set up. Because you've got quite a big part of the stuff. Bang. Okay. So shut down. Excellent.
Okay, while Jim's taking stuff apart, did anybody
that's
want to
a
ask
really
any
good time.
questions?
I had some really cool demos of stuff going over the networking bike.
Gentleman here?
So here you use the Pi Zeros as Ethernet devices, but what else could you use them or have them as over?
There's quite a few things. It can pretend to be a serial port, which seems to be strangely iffy at times. Have you seen system hangs when using the serial port?
It can be a sound card, it can be a pen drive, it can be so many different things. But this is the easiest, or most interesting thing.
Using the whole. Great, no. What, are you looking for HDMI?
Yeah, this one.
There you go, that's an HDMI.
Yeah, it's not that spaghetti.
This is good.
Oh, cool.
Good. I've been utterly outclassed. Actually, do you want to put that together under here?
Are you saying for myself?
Sorry?
You saying?
Oh, yeah, absolutely.
Yeah, we'll go on that desk. So if we clear the desk, I'll get it all on there. Be nice if this.
Ouch! That wasn't me. This is basically, now I actually talked about using that cluster hack, which is very convenient, is the right word.
Yes.
This is doing it properly by comparison.
I wouldn't say this is properly, but
I think
take your...
What's the VGA?
Now, one of the catches with that is it all goes through the host type, which if you're into high performance, fault tolerance clustering, is a terrible way of doing it. You've got bottlenecks, you've got all sorts of trouble, and it's basically not good. I'll do this at the end.
So if you're the next talk, I think it's starts at 2:15, so we've actually got a quarter of an hour break, so if you wanted to take a quick break, please feel free to.
Yeah, sorry about that, Devin.